Hi everyone, welcome to our channel. Today we are going to solve the reverse substring between each pair of parentheses problem. Also, we will be comparing the code for the longest valid parenthesis problem with the present problem because it is one of the variation of it. So let us see this problem. So the problem says that you are given a string S and that consists of only lowercase English letters and brackets. So this means that it has only lowercase and one type of bracket. If we see the examples, then it has only one type of bracket, that is parenthesis. And the second point says that reverse the string in each pair of matching parentheses starting from the innermost one. So what does this mean? So let's take this example. So we can see that first we'll be reversing OC, that is the innermost bracket, and then we'll be appending the reversed with ET, and then we'll be reversing full. So how it will be happening? First the OC will be becoming CO, then later the last string inside this bracket is ETCO, and when we reverse it, it will become OCTE. And then as we go outer and outer, we'll be appending the innermost string with the outer and then reversing it. So this is the meaning of the second point. Now last point says that your result should not contain any brackets. So this means that as we are going from innermost brackets to the outermost, we will be removing all the brackets as we are reversing them in the order, and then at last only the string will be returned. As we can see that the return type is also string. Now let us look into constraints also. So the constraint says that okay, the length is from 1 to 2000 for the string, and it contains only lowercase English characters. And okay, as I said, there is only one type of bracket, that is parenthesis, and it is guaranteed that all the parentheses are balanced. We don't have to check for balance. So in the next step, let us see some more examples to get a good understanding about this. And those examples will be based on some input and outputs and with some understanding. So in the first example, we can see that first we will be reversing this NG and CA because they are the innermost bracket strings, and then after that this full string will be reversed. So I've added the space just for understanding, so that's why you can ignore them, and you can see that I am removing the brackets as we are going further. So that's why the output for the example one is camping after reversing the brackets inside the string. So in the example two, we can see that first this OC will be reversed, and then after that this will be appended with the one outer string after reversing, and then that string will be reversed. At last, this full string will be reversed. So as I'm reversing, I'm also removing the brackets in order, and then at last, the output is lead code. That's why the output of example two is lead code. Now in this, we can see one thing is that as we go from left to right, whenever we encounter a closing bracket, we reverse the string inside that corresponding opening and closing bracket. And then again, when we get closing bracket, then we reverse it. So this means whenever a closing bracket is encountered, we have to do a operation. Now, one more thing we can notice here is that first, if if I reverse this, I'll remove the opening and closing bracket, but still this much I have to store it, correct? And then the recent one I will append this string, the reverse string. If you can see here, the reverse string is appended with the recently added string that is at the top. So that's why we need a data structure so that which can store the opening brackets as well as the strings, so that whenever the closing bracket comes, so I can know that okay, this much we have to reverse it together, what all the characters inside it. So that's why we have to store previous opening brackets and strings inside them in order. So in the next step, let us see if we can find some more inferences and note them down. So let us go to the next step. These are the inferences that we have noted down. So first is that when closing the bracket, then reverse. So if we see in first example, after ng there is a closing bracket, then we reverse ng, and then after ca there is a closing bracket when going from left to right, so we reverse ac. We make it ac and reverse ca. So that's why whenever there is a closing bracket, we have to reverse. Now, one more thing, the second point says that we need a data structure to store the previous brackets and strings. So yes, we need it because if we come to the example 2, we take OC, reverse it, then after that we append it with ET. So this means when we are going from left to right, we have to store the previous strings, that is ed, et, and then when coming back we have to, whenever we are encountering closing bracket, we have to take the previous strings also, append with them, and then reverse it. So that's why the stack would be the best data structure. Now the reason the stack would be the best, because if you can see here, with OC, ET is appended, and ET is the recently added, and the stack works on last in, first out. So the last entered, the recently entered will be at the top. So we'll be able to easily get it. So that's why we can use stack as a data structure. Now, after reversing, we have to concatenate. Yes, we have to concatenate because as we can see here, ETCO. So that's why. And and yes, the recent things should be reversed or at the top. So basically, the things which are recently entered will be definitely at the top in the stack. So they needs to be reversed. Now, in the next step, can we design a algorithm using this? So let us see that in next step. So following is the algorithm for the present problem. So first we'll be iterating from left to right, and there will be three steps that we will be following in the loop, and that will be first, if there is an open bracket, then we create a new string inside the stack. So basically that will be an element in the stack, and whenever there is a closing bracket, we will be popping out the top of the stack. That will be a string. The elements in the stack will be the string, and we'll reverse it and then append it at the top of the stack. So that will be the next element to which we are going to append the reverse string. Now, the last step would be if there is a character, we will be appending at the top of the stack. So totally three operation that will be happening, different operation inside the loop, because the string only contains three types of uh, different symbols. That is opening parenthesis, closing parenthesis, and a lowercase English alphabet. Now, when we come out of the loop after iterating full string, we will be popping out the string in the stack. That will be, there will be only one string because it has reached to the last and popped out all the brackets, and we have got our last string after doing all the operation. So that's why we'll be popping out, and that will be our answer. Now, for this example, let us try run this algorithm and see how it works. So before running the algorithm, just think that actually I have added this blocks just for me. So think that presently the stack has no element, and I will be making an arrow which will be indicating that there is an element created in the stack. So following is the input that I'll be try running. So there is the open bracket first. So if we have an open bracket, what we have to do is we have to create a new string at the top of the stack. So we will be creating a new string, and next we have uh, a character. Now, whenever we get a character, we actually append the character in the present string. So basically, the present string is at the top of the stack. So we will put the character here. Now we have D. Again, we'll be putting that here. Next, we have again open character, open bracket. So there will be again an element that will be created. Now we have E. So we will be putting a character inside the top element of the stack. We'll be appending actually. So there'll be a T, again a character. So we will be adding T. Now, whenever there's again a open bracket, so again, we have to create a new element in the stack. And then there is O. So it's character. So we'll be appending it at the top of the stack. Now C, we'll be appending it at the top of the stack. Why we are appending at the top of the stack? Because the element in stack are nothing but a string. Now, when we get a closing bracket, so what we do, we pop the string. So the string is OC. So let me pop it. And then, so the string was OC and I have to reverse it. So it was OC and then it becomes CO if we reverse this, correct? And then append with the top of the string in the stack. So this is at the top, there was OC and then we popped it out and then reverse it, then it becomes reverse it, so it will become CO. So let us append it at the top of the stack, CO. Now we'll go to the again next character because we have done all the operation of B step. So again there is a closing parenthesis. So pop and then reverse. So we can see that we actually if we see, this was the string, correct? ETCO. Now when we reverse it, it will be O C T E, correct? But the operation the algorithm will be doing is pop, then reverse it, that is OCTE. And then after that, what I'll be doing is append it with the top of the string. So let me append it. So let me append it O C T E, OCTE. Okay. Now all the operations are done because we have appended. Now again we have a E. So let me append it at the top because that is actually the top till now. L. Now I will add L. Now there is again a closing parenthesis. So three operation that will be happening in the second step inside the loop B. What is that? Pop it out. So this string will be popped out and reverse it. Now when we reverse it, what it will be? LEETCODE, lead code, correct? So reversing is done and then append with the top of the stack. So that means that we will pop it out and we can see that okay, there is nothing in the stack, so we'll be reversing it and we'll come out of the loop. So reverse it. So first I'll be popping it out and then reversing it and then adding it inside the stack. So what it will be happening is when I come out, only this reversed one will be at the top of the stack. So that's why I will be having this as the answer. Now you can see that actually if we pop it out, we cannot uh, append it to something. So let's say I am popping it out. Now there's no element in the stack, correct? So what I'm going to append to it. So that's why in the initial stage, we have to create one element in the stack. That is before this loop, correct? Then only we can get our answer. So this will be having the answer stored for us. So that's why even before that, we have to create an empty element inside the stack so that it can take the answer in it because the lead code was remaining. So if we execute the B step, that will be popping it out the reverse of lead code, and then if we reverse it, it will become lead code. And then if we want to append it, there will be an empty block at the end of the stack which is created, and then we will be having answer in that. And when we come out of the loop, we will pop the string from the stack and return it. So following is the Java code for the given problem. We can see here that first we are creating a stack, and in that the element type is string builder. Why is that? Because it's little faster than string. So the next we add a new string inside the stack as an element, and that is needed because let us take this example. So once we have done everything, A, B, C, D, reversed it, after that, if you see, there is a closing bracket at last. So it will come to this step, and it has to pop it out and reverse it and then enter into the stack. So there is some element needed to hold the answer. So that's why we are adding this. Now inside the for loop, we are iterating full string, and whenever there is a open bracket, we add a new string because it will be a starting of a new string that needs to be reversed. And then whenever there is a closing bracket, what we do is we take the top element of the stack, pop it out, reverse it, and put it to the second element. So we have popped it out, so that's why second came at the top, and to that we are actually appending it. So later we will be, if it's just a character, then we just have to append at the top. That's all. So these are the three cases that we are handling. And at last, when we come out, there will be definitely a closing bracket because in the question it says the string is balanced. If we can see here in the constraint. So that's why there will be a closing bracket and we will be popping out and storing the answer. So that's why I have created this. And later this will be having the answer and we have to convert it into string as the string is the return type, and then we'll be returning it. So this was the Java code. In the next step, you will be seeing the complexity analysis of this problem. So let us see that in next step. If we see the time complexity, then we can see that it's big O of n squared. Now, why is that? Because the outer loop runs to n times where n represents the length of the string. And inside that, whenever there was a closing bracket, it used to reverse it. So that's also the complexity is big O of n. So that's why the time complexity is total. Time complexity is big O of n square because let us say there is a worst case that there are n letters and n brackets inside it. So every time it comes out, it reverse it and append, reverse it and append, reverse it and append. So that can lead to n squared time. And now coming to the space complexity, that is also O of n. What if there is one whole string with only one bracket? So that needs that O of n of space. So that's why it's big O of n. So these are the complexity analysis. Now, in the next step, we'll be comparing it with longest valid parenthesis about how the same code with how the different code with the similar concept can be used to solve this problem. So let us see that in next step. We compare it with the longest valid parenthesis problem. We can see that first we are iterating from left to right. So in our problem also we are iterating. Now in the longest valid parenthesis A, that is A problem, there were opening bracket and closing bracket. Again, here also we have opening bracket and closing bracket, and we are doing some logic. Only there are characters also in our B problem, so that's why the extra logic comes into picture. But otherwise, the structure remains the same. So that's why these two are similar. So these was the comparison between them, and it's just a little manipulation, and we can also solve this type of variation of it. And if you liked our explanation and if you understood really well, then do like and subscribe our channel. And till the next video, thank you.